Good afternoon, everyone, and welcome to my session at Subsurface World Tour. My name is Amit Rustgi. My session captures a critical inflection point in how we architect data platforms. For years, the central monolithic data warehouse was our fortress, a secure, reliable source of truth. But today, the business landscape demands not a fortress with thick walls, but an open, adaptable city that can grow and evolve. My session is about that architectural shift. We will explore Apache Iceberg as the foundational engine for modern data lakehouse, a paradigm that embraces flexibility without sacrificing reliability. So this journey is about the fundamentally rethinking how we build systems that are not only technically robust, but also agile and future-proof. Before I begin the deep dive, I would like to extend a sincere thank you to Dremio for presenting this Subsurface virtual event. It's an opportunity for us to share the ideas that push the industry forward. So with the spirit of collaboration in mind, let's get started with the exploration. To guide the discussion over the next 25 minutes, here's the agenda. First, I will establish a common understanding by examining the limitations of the traditional SQL data warehouses, the very system that powered the last generation of analytics but are now showing their age. I will then discuss the forces, the urgent business demands that are putting immense pressure on the old model, forcing us to look for a better way. This leads us to our core topic, Apache Iceberg as the Lakehouse engine. We will unpack its key capabilities in detail, focusing on how its intelligent partitioning eliminates waste, how it radically simplifies the traditionally complex world of ETL, and how its open design ensures true interoperability. Finally, because theory must meet practice, I will share actionable best practice for transitioning from the old world to the new, and we will reserve the time at the end for the questions, so please think of them as we go along. A bit about myself. For over 20 years, I have worked at the intersection of data, architecture, and AI. My role as an AI architecture is more than building models. It's about designing the entire data foundation they rely on. I have seen firsthand how bottlenecks in the data infrastructure become the single biggest blocker to the innovation. I'm deeply passionate about the topic because technologies like Apache Iceberg are surgically removing those very bottlenecks. They are transforming data platforms from being the rate limiting step to becoming a true catalyst for the insight and AI driven outcomes. So let's start with a candid reality check. The traditional SQL data warehouse has become the real warehouse of the business intelligence for decades. It gave us the structure, consistency, and performance equal access. However, as the volume, variety, and velocity of our data have exploded, the architecture that once provided the strength has begun to feel confining. What was once a solid foundation can start to resemble a walled garden, limiting what we can plant and how quickly we can harvest. It's a time to examine those walls closely. So let's talk about the limitation of the traditional SQL warehouses. So these limitations surface in three critical interrelated areas. First is issue of rigid schema that restrict agility. In a fast-moving business, data is dynamic. A marketing team launches a new campaign and needs to capture three new attributes. In a traditional SQL warehouse, adding those columns isn't just an alter table command. It's often a trigger a lengthy, disruptive, and expensive migration process. The data team becomes a bottleneck and the business speed suffers. The schema rigidity is in direct conflict with the need for the business agility. Second, we face the high cost of tightly coupled compute and storage. This model forces to provision and pay for peak processing capacity 24/7, even when the nightly jobs are idle. Scaling to handle a monthly report means permanently scaling up the entire cluster. It is inefficient and creates a constant challenge between a performance and budget. Finally, there is the weak support for modern data types like semi-structured JSON from application logs, nested data from events, or real-time events from the IoT sensors. The warehouse demands that these data be heavily transformed, flattened, and loaded before it can be used. This process forces a difficult choice: either lose the rich nested context within the data, context that might be crucial for a machine learning model, or build and maintain a complex, fragile pre-processing pipeline just to get the data to a starting line. This pre-processing overhead is where the countless data engineering hours are lost. So why has this become an urgent pressing issue right now? Because the nature of the data work itself has fundamentally changed. Modern workloads are qualitative different and they demand more from our infrastructure. We are no longer just dealing with the periodic batches of tidy transactional data. We are inundated with continuous streams of information like clickstream, sensor reading, financial text, and many more data types. We get unstructured and semi-structured data like images, text document, JSON payloads that hold immense potential value. Furthermore, the rise of the ML and AI pipelines has altered the requirements. These aren't just SQL queries looking for aggregates. They are the complex algorithms that need flexible, direct, and high throughput access to vast amount of both raw and feature engineering data. They need to scan petabytes to train a model, and they need to do it efficiently. But above all, the pace of the business has accelerated. The decision makers can't wait for a weekly report. They need to understand the customer behavior this hour, detect fraud this minute, and optimize supply chain in the real time. So the traditional cycle of ingesting the data overnight, transforming it by the evening, and load it by morning, and then finally report it, it is a cycle that breaks in the face of the modern demands for the speed. So this brings us to the heart of today's conversation and the key to breaking those walls: Apache Iceberg. It's essential to frame this correctly from the start. Iceberg is not merely another file format to add to the toolkit. Think of it as an intelligence governance and a performance layer. The engine that transforms a simple collection of data files into a cloud storage, into a fully managed, highly performance, and a reliable data lakehouse. It is the technology that brings warehouse like superpowers to the open, flexible data lake. So let's define the iceberg more concretely. At its core, iceberg is an open table format. This is crucial distinction. It's a specification for how to organize and manage the data as a table on top of open scalable object store like Amazon S3, Azure Data Lake, or Google Cloud Storage. This brings several advantages. First, full asset transaction to this open storage, which means you can confidently perform concurrent inserts, updates, and deletes, which are very common in GDPR requests, or merging change data without worrying about the data corruption or the reader seeing partial inconsistent results. It brings the reliability we trusted in the warehouses to the data lake. Second, it enables a true multi-engine access before Iceberg. If you use Spark for ETL and let's say another tool for BI, you often needed two separate duplicate copies of the data, each optimized for its specific tool. Iceberg eliminates this sort of duplication. It provides a single consistent interface so that tools like Spark, Flink, Trino, and even Python via pandas can all safely and efficiently read from and write to the exact same dataset simultaneously. You are no longer building silos for each processing engine. You are building a cohesive data platform where the best tool for any job can access the central source of truth. So, to appreciate its power more, let's examine some of the iceberg's key capabilities. First is the schema evolution with no downtime. So imagine your product team decides to rename a column from cust_id to customer ID for clarity. In a traditional system, this could break every dashboard, report, and a pipeline that references the old name. With Iceberg, you simply rename it. The table's metadata tracks down the changes. The downstream queries using the old name keeps working seamlessly, while the new queries can use the new name. So you can add new columns, reorder them, or even change data types in a backward compatible way, all without costly downtime or a complex migration project. Second is time travel and rollback. So this is like having a git of your data tables. If you have ever made a mistake in the data pipeline that corrupted the data load, or need an audit for a specific data set that looked like how it looked like in the last quarter, with the Iceberg, every changes create a new snapshot. You can simply query the table as of a specific time or a snapshot ID. You can, with a single command, roll the entire table back to the known good state. So this isn't just a convenience, it's a transformational feature for data governance, audit compliance, and developer peace of mind. And third is the performance via rich metadata. Iceberg doesn't just store your data, it maintains a sophisticated metadata layer that catalogs statistics for every data file, which means minimum and maximum values for each column, null counts, and much more. When you run a query like where some date column is equal to some date, the query engine consults the metadata first. It can instantly identify and skip the entire files that do not contain the data for that specific date. So this metadata pruning turns the full table scan into a surgical operation, dramatically speeding up the queries and reducing the computational cost. So let's delve deeper into the performance, specifically how Iceberg revolutionizes the data layout. Traditional partitioning, like high-style partition, require you to expose the partition columns in your file path and critically in your query filters. If you ever need to change a partitioning strategy, let's say from daily to hourly, it's a massive disruptive data rewrite. So Iceberg, it introduces two game changers. First is flexible partitioning strategy. You can partition by a column or by a transform value or even by bucket. But the second concept, which is called hidden partitioning, is the real breakthrough. You can define your table to be partitioned by, let's say, a function like date underscore trunk, but the user or the analyst querying the data never needs to know that. They simply write where some date column between a given date range, and Iceberg metadata layer automatically maps the time range to the correct partition. So this means you can evolve the physical layout of the performance regions without breaking a single existing query. So combining with the rich metadata we just discussed, this ensures that queries are incredibly efficient. They prune at the right partition level and at the file level, ensuring that the system only touches the absolute minimum set of bytes needed to answer the question, so thus slashing the IO and a cost. So now let's address one of the most profound impacts of Iceberg, its power to radically simplify and even eliminate the traditional ETL complexity. It attacks this problem from a three strategic angle. The first is direct access. With Iceberg, you can query the data in place on your object store. There is no mandatory load phase into a proprietary format. This enables multi-model access patterns. For example, a batch BI query or a streaming ingestion job or an interactive data science notebook, they can all work with the same table concurrently. So it also enables efficient incremental processing. Instead of scanning the entire table daily, you can easily identify and process only the new data since the last job. So second angle is the less pipeline fragmentation. In the old paradigm, you have one pipeline for batch, another for real time, and maybe a third for feeding into the data science model. So these pipelines duplicate logic and create consistency nightmares. Iceberg unifies this by providing a single table abstraction that seamlessly handles both massive batch writes and a real-time row-level insert. So you define the data quality and transformation logic once at the table level, and it applies to all the data entering it, regardless of the source. The third angle is establishing a single authoritative layer. So the iceberg becomes the undisputed golden source of truth. You manage it declaratively, defining retention policies, compaction schedules, and quality rules all on the table itself. The built-in snapshotting provide a complete, immutable audit trail of every change. So let's discuss a scenario. Imagine your analytics team in Tableau, your data science team is using a Jupyter notebook, and your operations team is using a real-time dashboard, all querying the same live iceberg table for their needs. There are no stale copies, no reconciliation dispute, and no lag for data scientists. So this is the power of eliminating ETL complexity. It collapses time to insight and unifies the data organization. So all these capabilities culminate in Iceberg superpower, which is unparalleled interoperability. As an open standard governed by the Apache Foundation, Iceberg is a vendor neutral and a cloud agnostic. Your Iceberg tables are portable across AWS, Azure, GCP, or on-premise. So you're not logged into a single vendor's ecosystem or pricing model. More importantly, this interoperability applies to processing engine. The same exact iceberg table can simultaneously fuel the business intelligence dashboard, serve as the training data set for a machine learning model in Spark, or be the sink for a real-time event processing job in Flink, and be queried ad hoc by the analyst using Trino. You are finally free to choose the best tool for each specific job based on the technical merits, not based on the tool the data is logged in. Iceberg turns the data lake from a storage silo into a versatile, high-performance data hub that serves the entire organization. So yeah, so all this vision is compelling, but I'm sure a practical question is in everybody's mind. This all sounds great, but without blowing up my existing operation, how do I move to it? The journey is as important as its destination, so let's discuss some pragmatic best practices for transitioning. So the key philosophy is to be strategic and iterative. So first, don't try to boil the ocean. Identify a high value, well understood data set where iceberg's benefit will be immediately visible. A perfect candidate is a large append-only fact table in the warehouse that is expensive to scan and query. So migrating this to Iceberg can demonstrate dramatic cost savings and performance gains early in the journey. Second, adopt an incremental migration approach. You don't need a risky big bang up cutover. You can start by writing new data for a specific product line or a region into an Iceberg table while the old system still runs. So now you can run your existing reports and new Iceberg tables queries in parallel. You can compare the results for validation, and you can migrate data by partition and by domain, building confidence as you go. And third thing is, remember to tune for the new paradigm. So the Lakehouse has the different knobs than the warehouse. Pay close attention to the metadata management, scheduled regular compaction jobs to merge small files that arise from the streaming insert, which keeps the query performance snappy. So plan your partition strategy thoughtfully at the outset, leveraging hidden partitioning to maintain the flexibility. By following these three practices, starting small, moving incrementally, and optimizing as you go, you can de-risk the transition and build momentum for a broader organizational shift. So in closing, I want to leave you with the thought Apache Iceberg is the master key designed to break down the walls of the traditional data warehouse. It is the enabling technology that allows us to realize the full promise of the Lakehouse architecture, an open, scalable, and cost-effective foundation built on the object storage. So the benefits are clear: dramatically improved query performance through intelligent pruning, significant cost reduction through decoupled compute and storage, and inherent reliability through asset transaction. But this impact goes much deeper. By providing flexible, consistent, and performant access to the data, Iceberg fundamentally establishes ML and AI readiness. It creates agile, unified data layer that both business intelligence and advanced analytics desperately need. So ultimately, this isn't a technology upgrade. It is about building a data foundation that is as dynamic, scalable, and responsive as the business it serves. So thank you so much for your time and attention today.